Did you know that Albert Einstein's brain was stolen after his death? In a bizarre turn of events, the pathologist who performed Einstein's autopsy took the brain without permission, hoping to uncover the secret of his genius. This strange tale is just one of many in the extraordinary life of Albert Einstein. From his early struggles as a rebel student to his later years as a reluctant celebrity, Einstein's story is filled with surprising twists. Join us as we separate fact from fiction and explore the man behind the myths. Albert Einstein's journey began on March 14, 1879, in the city of Ulm, Germany. Born into a Jewish family, young Albert was surrounded by an environment that would shape his future in unexpected ways. His father, Hermann, worked as an engineer, while his mother, Pauline, had a deep love for music. This blend of technical and artistic influences in his household would later play a crucial role in Einstein's approach to scientific thinking. As a child, Einstein was quiet and introspective, traits that would persist throughout his life. Contrary to what his parents initially feared, his late development of speech wasn't an indicator of limited intelligence. In fact, it was perhaps a sign of his deep, contemplative nature. The turning point in Einstein's childhood came when he was 5 years old, in the form of a simple compass given to him by his father. This small device, with its mysterious ability to always point north, ignited a spark of curiosity in young Albert that would never be extinguished. The compass introduced him to the concept of invisible forces, a notion that would fascinate him for the rest of his life. It was as if the compass had opened a door to a hidden world, one that Einstein was determined to explore and understand. Despite the popular myth that Einstein struggled with mathematics in his youth, he actually excelled in both math and physics from an early age. His true struggle lay not with the subjects themselves, but with the rigid and authoritarian German education system of the time. The strict, rote learning approach stifled Einstein's natural curiosity and creative thinking. He found himself at odds with a system that valued conformity over independent thought. Music became a refuge for Einstein during these challenging school years. He developed a particular fondness for Mozart, whose compositions seemed to speak to him on a profound level. Einstein himself became an accomplished violinist, often turning to his instrument for solace and inspiration. The harmony and structure of music would later influence his scientific thinking, helping him to see patterns and connections in the universe that others might miss. By the age of 15, Einstein's frustration with traditional schooling reached a breaking point. In a decision that would have been shocking to many, he chose to drop out of school without obtaining a diploma. This bold move coincided with his family's relocation to Italy, where they sought new business opportunities. Far from being the end of his educational journey, this period marked the beginning of Einstein's self-directed quest for knowledge. Free from the constraints of formal education, Einstein's passion for science and mathematics flourished. He spent countless hours reading and contemplating scientific texts, developing his own ideas and theories. This time in Italy was crucial in shaping Einstein's independent thinking and his unique approach to scientific problems. It was here that he began to question established scientific principles and imagine new possibilities for understanding the universe. Einstein's early experiences laid the foundation for his future revolutionary work in physics. The compass that sparked his curiosity about invisible forces would lead him to explore the nature of light and gravity. His struggles with the education system fostered a healthy skepticism of established authority, allowing him to challenge prevailing scientific theories. And the creative inspiration he found in music would inform his ability to imagine abstract concepts and visualize complex physical phenomena. As Einstein stepped into the halls of the Swiss Federal Polytechnic in Zurich in 1896, he was about to embark on a journey that would challenge not only his intellect, but also his ability to conform to academic norms. At 17, the young Einstein was determined to become a physics and mathematics teacher, but his unconventional approach to learning would soon set him on a collision course with the rigid educational system of the time. From the outset, Einstein's passion for science was evident, but so was his disdain for traditional teaching methods. He found himself at odds with his professors, rejecting the emphasis on rote memorization and strict adherence to academic traditions. For Einstein, these practices stifled creativity and hindered true understanding. Instead, he sought to explore scientific concepts through deep, independent thought and analysis. While Einstein excelled in theoretical physics, his academic record was far from spotless. He showed little interest in subjects outside his focus, often skipping classes to pursue his own studies. This self-directed approach led him to immerse himself in the works of scientific giants like Newton and Maxwell, as well as the philosophical writings of Kant. These independent explorations laid the groundwork for his future groundbreaking theories, but they did little to endear him to his professors. Despite his rebellious nature, Einstein found kindred spirits among his peers. He formed close friendships with like-minded students, including Marcel Grossmann, whose meticulous note-taking proved invaluable to Einstein. Grossmann's detailed class notes often helped Einstein pass exams for courses he had rarely attended. Another significant relationship formed during this time was with Mileva Maritz, a fellow physics student who became Einstein's confidant and intellectual partner. Einstein's time at the Swiss Federal Polytechnic was marked by a constant tension between his brilliant mind and his inability, or unwillingness, to conform to academic expectations. His disregard for authority and unconventional study habits strained relationships with his professors. While his performance in physics was strong, his rebellious reputation left him with few job prospects as graduation approached. However, this period of academic rebellion was crucial in shaping Einstein's scientific mind. The resistance he faced from the established academic system only strengthened his resolve to question accepted ideas and think independently. These qualities, which caused him trouble as a student, would later become the driving force behind his revolutionary scientific contributions. As Einstein approached graduation in 1900, he had developed a deep love for physics and a powerful ability to challenge established ideas. However, his unconventional approach to education had left him ill-equipped to navigate the traditional academic career path. He graduated with a teaching diploma, but found himself struggling to secure an academic position. The young Einstein's difficulty in finding work in academia would soon lead him down an unexpected path, one that would ultimately change the course of scientific history. His time as a rebel student had honed his ability to think outside the box and pursue ideas that others might dismiss. These skills, combined with his deep understanding of theoretical physics, were about to find an unlikely home in a Swiss patent office. As Einstein settled into his role as a patent clerk in Bern in 1902, Few could have predicted that this unremarkable position would become the launchpad for theories that would reshape our understanding of the universe. The Swiss Patent Office, a bustling hub of innovation and bureaucracy, became the unlikely crucible for some of the most revolutionary ideas in physics. But how could a mundane desk job spark such groundbreaking scientific thought? The answer lies in the unique combination of stability and intellectual freedom that Einstein's new position afforded him. While the work itself was far removed from the cutting-edge theoretical physics he craved, it provided him with a steady income and, more importantly, ample free time to pursue his scientific interests. The routine nature of reviewing technical documents on inventions allowed Einstein's mind to wander and explore the complex questions that had long fascinated him. It was during these seemingly mundane hours that Einstein developed his habit of conducting thought experiments, a practice that would become central to his scientific method. Instead of relying solely on traditional laboratory experiments, he would imagine complex physical scenarios in his mind, manipulating variables and observing the theoretical outcomes. This approach, born out of necessity in the absence of a formal research position, would prove invaluable in developing his groundbreaking theories. The Patent Office also provided an unexpected benefit. It fostered Einstein's ability to think independently, free from the constraints and pressures of academic institutions. Without the need to conform to established scientific norms or chase academic accolades, Einstein was able to explore unconventional ideas that might have been dismissed in more traditional settings. During this period, Einstein's intellectual pursuits extended beyond the confines of his workday. He formed the Olympia Academy, an informal discussion group with friends Maurice Slovin and Konrad Habecht. This small circle met regularly to debate topics in philosophy, physics, and mathematics, challenging conventional ideas and pushing the boundaries of their understanding. These discussions provided Einstein with a much-needed intellectual outlet and helped refine his thinking on various scientific concepts. Despite working outside academia, Einstein's passion for physics remained undiminished. In the evenings and on weekends, he devoted himself to intense study and contemplation, producing groundbreaking papers that would soon transform the world of physics. At the time, however, these works went largely unnoticed by the broader scientific community, written by an unknown patent clerk in his spare time. The Patent Office became an unexpected incubator for Einstein's revolutionary ideas. The combination of financial stability, ample free time, and freedom from academic pressures created the perfect environment for his genius to flourish. This period of relative obscurity allowed Einstein to develop his theories without the scrutiny or interference of the established scientific community, giving him the freedom to pursue ideas that might have been considered too radical in academic circles. As Einstein reviewed patent applications by day and pondered the nature of the universe by night, he was unknowingly laying the groundwork for what would become known as his miracle year in 1905. The theories he developed during this time would not only transform our understanding of physics, but would also catapult him from obscurity to worldwide fame. In 1905, while still working at the Swiss Patent Office, Einstein published a paper that would shake the foundations of our understanding of the universe. Titled On the Electrodynamics of Moving Bodies, this groundbreaking work introduced the theory of special relativity. Einstein's theory proposed a radical idea. Time and space, long believed to be absolute and unchanging, were actually interconnected and relative to the observer's motion. This concept was a direct challenge to the classical Newtonian mechanics that had dominated physics for centuries. At the heart of special relativity was a simple yet profound assertion: the speed of light is constant for all observers, regardless of their movement. To arrive at these extraordinary conclusions, Einstein relied not on complex laboratory experiments, but on thought experiments. He imagined scenarios that pushed the boundaries of physics, such as what one might see if they could ride alongside a beam of light. This approach allowed him to explore the implications of his ideas in ways that physical experiments of the time could not. One of the most famous outcomes of special relativity was the equation E equals mc squared. This elegant formula revealed that mass and energy are interchangeable, a concept that would later become the foundation of modern nuclear physics. It suggested that even a small amount of mass could be converted into an enormous amount of energy, a principle that would have far-reaching consequences in the decades to come. What made Einstein's paper truly revolutionary was its ability to simplify complex concepts without relying on advanced mathematics. By making profound connections between space, time, and energy, Einstein presented a new way of thinking about the universe that was both elegant and accessible. This approach would become the hallmark of his work throughout his career. Initially, Einstein's paper received little attention from the scientific community. However, as more physicists began to grasp the implications of his work, interest in special relativity grew. The theory's ability to explain phenomena that classical physics could not, such as the behavior of particles at extremely high speeds, soon caught the eye of prominent scientists. As the implications of special relativity became clear, it transformed not just physics, but our entire understanding of the universe. The theory challenged our perception of the fundamental nature of reality, suggesting that our everyday experiences of time and space were just a limited perspective of a much more complex universe. The impact of special relativity extended far beyond the realm of theoretical physics. It laid the groundwork for future technological advancements, from GPS systems to particle accelerators. The theory's influence can be seen in fields as diverse as philosophy, art, and popular culture, as people grappled with the implications of a relative universe. Einstein's work on special relativity marked the beginning of a new era in physics. It paved the way for further groundbreaking theories, including his later work on general relativity. The paper also established Einstein as a rising star in the scientific community, setting the stage for his transformation from an unknown patent clerk into a world-renowned physicist. As Einstein's groundbreaking work in 1905 reverberated through the scientific community, his reputation began to soar. The once obscure patent clerk was now catching the attention of leading physicists across Europe. His innovative ideas and ability to challenge conventional wisdom set him apart, marking the beginning of a remarkable ascent in the world of academia. In 1909, Einstein secured his first academic position as a professor at the University of Zurich. This transition from patent clerk to respected academic was a pivotal moment in his career. It provided him with the platform he needed to further develop and share his revolutionary ideas. The halls of academia, once closed to him, now welcomed Einstein with open arms. But Zurich was just the beginning. Einstein's growing reputation soon led to more prestigious appointments. He accepted a position at the German University in Prague, where he continued to refine his theories and engage with fellow scientists. However, it was his move to the University of Berlin in 1914 that truly catapulted him into the upper echelons of the scientific community. Here, Einstein found greater freedom to focus on theoretical research, allowing his mind to wander into the realms of the unknown. During this period, Einstein's circle of influence expanded dramatically. He engaged in intense scientific discussions with some of the most brilliant minds of his time. Max Planck, the father of quantum theory, became a close colleague and supporter. Niels Bohr, whose work on atomic structure would revolutionize physics, exchanged ideas with Einstein, leading to heated debates that would shape the future of quantum mechanics. These interactions were more than mere academic exercises. They were intellectual sparring matches that pushed the boundaries of scientific thought. Einstein's ability to think outside the box and challenge established norms inspired a new generation of physicists. Young scientists, emboldened by Einstein's example, began to explore uncharted areas of theoretical physics, ushering in a new era of scientific discovery. As Einstein's fame grew, so did the demand for his presence at international lectures and conferences. He found himself traveling across Europe, sharing his revolutionary ideas with wider audiences. From London to Paris, Einstein's lectures drew crowds of scientists eager to hear from the man who had turned physics on its head. These international engagements not only spread Einstein's ideas, but also solidified his position as a global scientific figure. Between 1912 and 1915, Einstein's focus shifted to one of the most perplexing problems in physics: the nature of gravity. Isaac Newton's theory of gravity had stood for centuries, but Einstein sensed there was more to the story. He embarked on an intense period of study and contemplation, grappling with complex mathematical equations and pushing the limits of his imagination. This quest to understand gravity consumed Einstein. He worked tirelessly, often neglecting sleep and meals as he pursued his goal. The challenge was immense, requiring him to rethink fundamental concepts of space and time. But Einstein was undeterred. He knew that solving this puzzle would not only redefine physics, but also revolutionize humanity's understanding of the universe. Einstein's tireless pursuit was about to pay off in ways he couldn't have imagined. After nearly a decade of relentless work, he was on the brink of unveiling a theory that would reshape our understanding of the universe. In 1915, Einstein presented his crowning achievement, the general theory of relativity. This groundbreaking theory proposed a radical new view of gravity that would challenge centuries of established physics. Unlike previous theories, Einstein suggested that gravity isn't a force at all. Instead, he proposed that massive objects like stars and planets actually bend the fabric of space and time around them. This warping of space-time, Einstein argued, is what we experience as gravity. It was a concept so revolutionary that it seemed almost impossible to prove. Einstein's field equations, the mathematical backbone of his theory, described how mass and energy curve space-time and how this curvature, in turn, influences the motion of other objects. This elegant explanation stood in stark contrast to Newton's classical view of gravity as a force acting between objects. But Einstein's theory made a bold prediction that would set the stage for its ultimate confirmation. Light itself should bend when passing near a massive object. This idea was met with skepticism from many in the scientific community. After all, light had always been thought to travel in straight lines. How could it possibly bend? Einstein, however, was confident in his calculations. He knew that if his theory was correct, this bending of light could be observed during a total solar eclipse, when the sun's overwhelming brightness wouldn't obscure nearby stars. The opportunity to test Einstein's prediction came in 1919. Sir Arthur Eddington, a British astronomer, led an expedition to observe a solar eclipse from two locations, the island of Príncipe off the west coast of Africa and Sobral in northern Brazil. The goal was to photograph the positions of stars near the edge of the eclipsed sun and compare them to their normal positions. The expedition was a monumental undertaking. Eddington and his team had to transport delicate astronomical equipment to remote locations, battling unfavorable weather conditions and the aftermath of World War I. Despite these challenges, they managed to capture several clear photographs during the eclipse. When the idea was analyzed, the results were clear. The positions of the stars had indeed shifted, just as Einstein's theory had predicted. Light from distant stars had been bent by the sun's gravity, causing their apparent positions to change. The amount of deflection matched Einstein's calculations with remarkable accuracy. The confirmation of Einstein's theory sent shockwaves through the scientific world and beyond. Newspapers around the globe trumpeted the news, catapulting Einstein from a respected scientist to an international celebrity almost overnight. The London Times ran the headline, "Revolution in Science, New Theory of the Universe, Newtonian Ideas Overthrown." Einstein's general theory of relativity didn't just change our understanding of gravity, it opened up entirely new fields of study. It laid the foundation for modern cosmology, providing the framework to explore concepts like black holes, the expanding universe, and gravitational waves. These ideas, once considered purely theoretical, have since been confirmed through observations and experiments, further solidifying Einstein's legacy. Over a century after its inception, general relativity remains one of the cornerstones of modern physics. Its predictions continue to be validated by new scientific discoveries, from the detection of gravitational waves in 2015 to the first image of a black hole in 2019. These confirmations stand as a testament to the enduring power of Einstein's ideas and his unparalleled ability to unravel the mysteries of the cosmos. Behind the iconic image of Albert Einstein, with his wild hair and brilliant mind, lay a complex personal life filled with love, family, and struggles. While his scientific discoveries revolutionized our understanding of the universe, Einstein's relationships were often marked by turmoil and emotional distance. In 1903, Einstein married Mileva Maritz, a fellow physics student he had met during his time at the Swiss Federal Polytechnic. Their union produced two sons, Hans Albert and Eduard. However, as Einstein's fame grew, so did the strain on their marriage. His increasing focus on his work and emotional detachment began to take a toll on their relationship. The deterioration of their marriage culminated in a divorce in 1919. That same year, Einstein married his cousin, Elsa Lowenthal. Elsa proved to be a stabilizing force in Einstein's life, providing support and managing his affairs as he rose to global prominence. Her presence allowed Einstein to focus more intensely on his scientific pursuits, but it also highlighted the complexity of his personal relationships. Einstein's relationships with his children were particularly complicated. While he maintained some connection with his eldest son, Hans Albert, his relationship with Eduard was notably distant. Eduard's struggles with mental health issues later in life became a source of profound sorrow for Einstein, who felt a sense of guilt and helplessness in the face of his son's suffering. Known for his nonconformist views on love and marriage, Einstein engaged in several extramarital affairs throughout his life. These relationships added another layer of tension to his personal life and further strained his marriages. Einstein's approach to romance was as unconventional as his scientific theories, often leading to conflict and heartache for those closest to him. Despite his public image as a pacifist and intellectual giant, Einstein frequently grappled with feelings of isolation. His work consumed much of his attention, leaving little room for deep emotional connections. This internal struggle between his dedication to science and his personal relationships was a recurring theme throughout his life. In the midst of his personal turmoil, Einstein found solace in music. An avid violinist, he often turned to classical compositions for comfort and inspiration. Einstein claimed that playing music helped him think more clearly, providing a much-needed respite from the complexities of his scientific work and personal life. Einstein's personal life reflected the contradictions inherent in his character. He was a man deeply connected to the mysteries of the universe, yet often distant from those closest to him. His brilliant mind could unravel the secrets of time and space, but he struggled to navigate the intricacies of human relationships. The juxtaposition between Einstein's public and private personas was stark. While the world celebrated him as a genius and visionary, those who knew him intimately often experienced a different side of the man. His personal struggles and shortcomings serve as a reminder that even the greatest minds are not immune to the challenges of human relationships and emotions. As the dark clouds of fascism gathered over Europe in the early 1930s, Albert Einstein found himself at the center of a brewing storm. The rise of the Nazi Party in Germany brought with it a wave of anti-Semitism and hostility towards intellectuals, particularly those of Jewish heritage. Einstein, already a world-renowned physicist and a vocal pacifist, suddenly became a prime target for the regime's propaganda machine. The Nazis, in their quest to purge German society of what they deemed un-German influences, began a systematic campaign against Einstein and his work. His groundbreaking theories were dismissively labeled as Jewish physics, a term loaded with racial prejudice and scientific ignorance. This wasn't just an attack on Einstein's ideas. It was an assault on the very foundations of scientific inquiry and rational thought. As Hitler's grip on power tightened, Einstein's position in German society became increasingly precarious. The Prussian Academy of Sciences, once a bastion of intellectual freedom, now found itself under pressure to conform to Nazi ideology. Einstein, sensing the shifting winds, made a decision that would alter the course of his life and potentially save it. In 1933, while on a lecture tour in the United States, news reached Einstein that Hitler had ascended to power in Germany. With remarkable foresight, Einstein recognized the grave danger that awaited him if he were to return. He made the difficult but necessary choice to remain in America, effectively becoming an exile from his homeland. The consequences of Einstein's decision were swift and severe. Back in Germany, his property was seized by the Nazi regime. In a chilling display of anti-intellectualism, his books were thrown onto bonfires during public demonstrations. These book burnings, organized by Nazi student groups, were symbolic acts meant to purge German culture of un-German ideas. Einstein's works, along with those of many other Jewish and dissenting authors, went up in flames. But the threats against Einstein weren't limited to his property and ideas. Nazi sympathizers, emboldened by the regime's rhetoric, placed a bounty on his head. The man who had revolutionized our understanding of the universe now found his very life in danger because of the narrow-mindedness and hatred of those in power. In response to these events, Einstein took a bold stand. He publicly condemned the Nazi regime, using his international fame as a platform to speak out against the atrocities being committed in Germany. In a symbolic act of defiance, he renounced his German citizenship. This wasn't the first time Einstein had taken such a leap. He had also given up his German citizenship in his youth before acquiring Swiss nationality. Now, once again, he found himself stateless, a man without a country. Einstein's exile led him to the United States, where he found a new home at the Institute for Advanced Study in Princeton, New Jersey. This newly established institution would become his intellectual sanctuary for the remainder of his life. Here, far from the turmoil of Europe, Einstein continued his scientific work while also taking on a new role as an advocate for refugees. The physicist's experiences with the Nazi regime had a profound impact on his worldview. Einstein, long known for his pacifist beliefs, found himself grappling with the harsh realities of a world sliding towards global conflict. His staunch opposition to violence was now challenged by the very real threat posed by fascism. This internal struggle led Einstein to adopt a more pragmatic stance, recognizing that sometimes the defense of freedom and human rights might require action. In the years that followed, Einstein used his considerable influence to support efforts to help other Jewish intellectuals escape Nazi persecution. He wrote letters of recommendation, used his contacts to secure positions for refugees, and spoke out tirelessly about the dangers of fascism. His actions helped save numerous lives and preserved a wealth of intellectual talent that might otherwise have been lost to the Holocaust. As World War II raged across Europe, Albert Einstein faced a profound moral dilemma that would challenge his deepest beliefs. The world's most famous pacifist found himself advocating for the development of the deadliest weapon in human history. In 1939, with the looming threat of Nazi Germany potentially creating nuclear weapons, Einstein took an unprecedented step that would forever change the course of history. Alongside fellow physicist Leo Szilard, Einstein signed a letter to U.S. President Franklin D. Roosevelt. This letter urged the United States to pursue atomic bomb research, warning of the potential consequences if Germany were to develop such a weapon first. The missive played a crucial role in the creation of the Manhattan Project, a top-secret program that would ultimately lead to the development of the first atomic bombs. Ironically, It was Einstein's groundbreaking work in physics that laid the theoretical foundation for nuclear energy. His famous equation, E equals mc squared, demonstrated the enormous potential energy locked within matter. However, Einstein himself had no direct involvement in the Manhattan Project. His role was limited to that initial letter, which set the wheels in motion for one of the most significant and controversial scientific endeavors in human history. As a lifelong pacifist, Einstein grappled with the weight of his decision. He supported the bomb's development out of fear of Nazi Germany's potential capabilities, but the destructive power of such a weapon deeply troubled him. This internal conflict exemplified the broader ethical struggles faced by many scientists during wartime, where the pursuit of knowledge could lead to unprecedented devastation. The true impact of Einstein's decision became painfully clear in August 1945. When atomic bombs were dropped on the Japanese cities of Hiroshima and Nagasaki, resulting in catastrophic civilian casualties. Einstein was shocked and devastated. The theoretical concepts he had explored in his work had been transformed into a weapon of mass destruction, forever altering the landscape of global politics and warfare. In the aftermath of the war, Einstein expressed deep regret for his role in initiating the atomic bomb project. He later stated that if he had known Germany wouldn't succeed in developing the bomb, he would never have signed the letter to Roosevelt. This admission highlighted the complex interplay between scientific advancement and ethical responsibility, a theme that would dominate Einstein's later years. Driven by his remorse and concern for the future of humanity, Einstein became an outspoken advocate for nuclear disarmament and global peace. He co-founded the Emergency Committee of Atomic Scientists, an organization dedicated to warning the public about the dangers of nuclear proliferation. Einstein used his platform and influence to call for international cooperation and the responsible use of scientific knowledge. The atomic bomb became a symbol of both Einstein's scientific legacy and his ethical struggle. It underscored the tension between the pursuit of knowledge and the potential for that knowledge to be used for destructive purposes. Einstein's journey from theoretical physicist to reluctant contributor to the atomic age, and finally to peace advocate, reflected the broader challenges faced by the scientific community in the mid-20th century. As the dust settled from World War II, Einstein turned his gaze from the atomic bomb to an even more elusive target. What challenge could possibly occupy the mind that had unlocked the secrets of space and time? The answer lies in a theory that eluded even Einstein until his dying day. In the final decade of his life, Albert Einstein retreated from the spotlight to the tranquil halls of the Institute for Advanced Study in Princeton, New Jersey. Here, surrounded by fellow intellectuals and far from the clamor of public life, he embarked on his most ambitious scientific quest yet, the pursuit of a unified field theory. This grand endeavor aimed to reconcile the forces of gravity and electromagnetism into a single, elegant framework, a goal that would consume Einstein's thoughts until the very end. While Einstein grappled with the complexities of unification, the world of physics moved on without him. The rise of quantum mechanics, a field he had helped pioneer but grew to criticize, dominated scientific discourse. Einstein's famous quip, "God does not play dice with the universe," encapsulated his discomfort with the probabilistic nature of quantum theory. This stance increasingly isolated him from the mainstream scientific community, yet Einstein remained undeterred, convinced that a deterministic explanation of the universe was within reach. Beyond the realm of physics, Einstein's later years were marked by a deep commitment to social and political causes. The specter of nuclear annihilation loomed large in the post-war world, and Einstein used his considerable influence to advocate for global disarmament. He warned tirelessly of the dangers of nuclear proliferation, urging world leaders to seek peaceful resolutions to international conflicts. Einstein's conscience extended beyond the nuclear issue to encompass civil rights in his adopted homeland. In an America still grappling with racial segregation, Einstein's voice rang out in support of equality. He joined the National Association for the Advancement of Colored People, or NAACP, and corresponded with civil rights leaders like W.E.B. Du Bois. Einstein's commitment to justice was not merely theoretical. He actively participated in efforts to desegregate Princeton and spoke out against racial discrimination whenever he encountered it. Despite the weighty issues that occupied his mind, Einstein never lost his sense of wonder and humility. He found joy in simple pleasures, sailing on nearby lakes, playing his beloved violin, and engaging in lively correspondence with friends and fellow thinkers around the world. His wit and humor remained sharp, often deployed to deflect attention from his celebrity status. When asked how it felt to be the smartest man in the world, Einstein reportedly quipped, "I don't know. You'll have to ask Nikola Tesla." In 1952, Einstein received an extraordinary offer: the presidency of the newly formed State of Israel. It was a testament to his global stature and his lifelong commitment to Jewish causes. Yet, true to his humble nature, Einstein declined the position. He felt that his lack of political experience would make him ill-suited for such a crucial role in the fledgling nation's future. As his life drew to a close, Einstein remained the quintessential philosopher-scientist. His insatiable curiosity, paired with a deep concern for humanity's future, drove him to continue questioning, exploring, and advocating until the very end. On April 18, 1955, Einstein spoke his final words in German, a language that had once rejected him, but which he had never fully abandoned. These words were lost to the ears of his nurse, who did not understand the language, leaving us with a final mystery from a man who had spent his life unraveling the secrets of the universe. Albert Einstein's life was a remarkable journey, from a curious child with a simple compass to a scientific icon whose theories reshaped our understanding of the universe. Einstein was more than just a genius in a lab. He was a humanitarian, a philosopher, and a relentless advocate for peace, freedom, and justice. If you enjoyed this deep dive into Einstein's life, don't forget to like and subscribe for more fascinating stories about history's greatest minds.